In the previous lectures, we provided many examples of methods calling other methods, but we didn't show an example of a method calling itself. If you are not used to it, the idea of a method calling itself probably seems strange. Although it is not all that common for a method to call itself, the technique can be used for elegant solutions to problems that are otherwise would be very difficult to solve. A method that calls itself is known as a recursive method, and a program is said to have recursion if it relies on recursive method calls. To motivate you for understanding recursion, let us have the following example. Before discussing recursion in details, and before showing you how to design a recursive algorithm or how to trace an algorithm that is recursive, we would like to introduce our lecture by the following motivated example. In this example, we want to write a method called countdown that has an integer input parameter called num. This method is called countdown and it has only one input parameter of type integer and called num. The method simply outputs all of the numbers from num down to 1. So for example, if the input parameter num is 4, and when we call this method, then the method will display on the output screen the numbers 4, 3, 2, down to 1. Such a program can obviously be written with a simple for loop. The for loop is the preferred method for this problem, but we will provide a recursive countdown method to illustrate how recursion works for a simple example. And later, we will see other problems for which recursion is the more elegant and a preferred solution. Before we describe a design for a recursive algorithm for this method, we would like to introduce the following notation. The notation that we are going to use for calling the method is similar to calling a function in mathematics. So in mathematics, we usually use function names like f of x or g of x or h of x. Now we are going to use the same notation for our methods. For our example, we have countdown and between brackets we have the number 4. So we want to call the method when the input parameter is equal to 4. Now this method is simply printing the numbers 4, 3, 2, and 1 separated by tabs. All these numbers are on a single line. As we have mentioned before, that we can implement this method by using a for loop. So we could have a countdown for loop. In every iteration, we print the number 4, 3, 2, down to 1. And this method is called iterative method. But we would like to show you how to do the same thing by printing the numbers 4, 3, 2, 1 using a recursive algorithm that a method calls itself. So let us start describing how we can do this. Now when we look closely on the output that is generated when we call the method with input parameter, let's say num, it prints all numbers starting from num down to 1 all on a single line. So in our example, when we call the method countdown with the input parameter 4, then it is going to print 4, 3, 2, and 1. Now what if this input parameter is 5? Then it's going to print the numbers 5, 4, 3, down to 1. What if it is 10? Then it's going to print the numbers 10, 9, 8, all down to 1, all on a single line. So now when we call the method with input parameter 4, then the method is expected to produce the output 4, 3, 2, and 1. But notice that the last 3 numbers are in fact the output when we call the same method with input parameter 3. So for countdown 4, instead of printing all the numbers, it prints only the first number. And for printing 3, 2, and 1, it simply calls the same method but with input parameter 3. Now let us see what is the output generated when we call the method countdown with input parameter 3. It is going to print 3, 2, and 1. And similarly for the last 2 numbers, it is in fact the output when we call the same method but with input parameter 2. Now let us see what is the output generated when we call the method with input parameter 2. The output is 2 and 1. And see the last number 1 also can be generated by calling the same method with input parameter and 1. And last, when we call the method countdown with input parameter 1, it is going to produce or output only one number. So there are no other numbers to be displayed so that we can call the method countdown again. Therefore, the last case is considered as the base case and it stops calling the same method again. So for countdown 4, it is calling countdown 3. And for countdown 3, it is calling countdown 2. And all the way down, for countdown 1, it does not call the method again. It simply prints the number 1. So now we can generalize the notation here. And instead of 4, we can generalize it with the input parameter num. And we say that the method countdown, if it has input parameter num, simply first it prints the number num, and then it calls the same method but with input parameter num minus 1. And this is what we have seen in each stage or in each case, that for countdown for any number, it is calling countdown with 1 less than this number. So after splitting the main task of the method with the input parameter num into successive subtasks using the same method but with a smaller input parameter num minus 1, and also after identifying the stopping condition or the base case, the question is how to implement the recursive body of the method. So to implement the recursive body of this method, we need branching. And now for our branching, we need only if and else statement, because we have two conditions. The first condition is the base case, and the other condition if it is not the base case. Sometimes for recursive algorithms, we need multi-branching selection. Maybe we could have more than one base case. So therefore, we need if else statement to use inside the body of the method. So the implementation for this method in Java, we write if and else statement. If the input parameter num is equal to 1, which is the base case, then it simply prints 1 followed by a new line. However, if the input parameter num is not equal to 1, then we need to implement the recursive algorithm. As you notice here, first we print num, so we are printing num followed by tab. Then we call the method recursively but with input parameter num minus 1, and this is what we are doing in the second line of the else statement. So we need braces, the curly braces, because we have to do two things under else, a print, and then we call the method recursively. Let us have a little demonstration showing you how to implement the countdown recursive method. First, we need to define the method. It's going to be private, static, void, and it is called countdown, and the input parameter is integer num. As we mentioned that for recursive algorithms, we implement branching inside the method. So we will start with the base case. So we say if num equal 1. And for the base case, we print the value 1 followed by a new line. For the else statement, we need to do two things. First, we need to print the current value of num. So we say system dot out dot print, and we print num followed by a tab, and then we call the method recursively by saying countdown with the input parameter num minus 1. And this completes the implementation for the recursive method. To test the method, we need to call it from the main method with input parameter. Let us say we want to test it with input parameter 4. So let us run the program, and as you can see that the numbers are printed 4, 3, 2, and 1. Let us trace the program step by step using the canvas viewer. So now we are running the canvas viewer. We need to go inside the method, so we are going to click this button, and now we are inside the method for the first call. And for the first call, the value of num is equal to 4. So 4 is not equal to 1. So therefore, it will skip the condition for the if statement and it will go to else. Inside else, we print the current value of num, which is 4. So as you can see on the output screen, we have the number 4 printed. And now we are calling the same method, but this time with input parameter num minus 1. The current value of num is 4. We are supplying a 3 and we are calling the method again. So it's going to be the second call. But the first call, that when num is equal to 4, still did not finish. It will be suspended. So let us go for the second call. And as you can see, we are calling the method again with the input parameter 3. And 3 is not equal to 1, so it will skip the condition. But notice there is a gray arrow at line 15. That means that the previous call still did not complete, and we are calling the method again with num equal to 3. And again, we are going to call the method for the third time with num is equal to 2, because num, the current value of num is 3. And now we are in line 14. We are going to print the value, which is equal to 3. And now we are calling the method the third time, but this time the input parameter is 2, because we have num minus 1. And when we go inside the method, still num is not equal to 1, so it will print the value of num, which is 3, and it is going to call the method for the fourth time, but with input parameter 1. Because num minus 1 is 1, so we are going to call the method when num is equal to 1. Now the condition is true, so it is going to print 1, and there is no call for the method. So therefore, for the last call, when num is equal to 1, we are going to exit the method, and then we will go back for all the calls that happened before for the method. So it will go all together at the end, and as you notice that we are at the end of the program, and the program is terminated.